Your phone charges through solid plastic with zero wires touching it, and up to 30% of that power just turns into heat. That sounds like a bad deal, so why does it work at all? It isn't beaming energy through the air like Wi-Fi. There's no invisible signal carrying power across your desk. The trick is a 190-year-old idea hiding inside two coils of wire. And once you see it, wireless charging stops looking wireless at all. Here's the setup. Inside your charging pad is a coil of wire. Inside your phone is a second coil of wire. Neither one touches the other. There's a layer of plastic and air in between. And yet, flip a switch, and current starts flowing in your phone's coil, pulled from nowhere you can see. To understand that, forget charging for a second and think about magnets. A lot of people assume this works like a tiny radio transmitter broadcasting electricity the way a phone tower broadcasts a signal. That's the myth, and it's wrong. You can't just fling raw electrical power through open air efficiently. If you could, it'd leak out of every charging pad and cook whatever was nearby. The real answer needs the two coils to be almost touching for a very specific reason. The pad's coil isn't just holding a current. It's an oscillating one, switching direction tens of thousands of times a second. A changing current always builds a changing magnetic field around itself. That field reaches out from the pad and washes over your phone's coil, sitting just above it. And a magnetic field that keeps changing, moving through a loop of wire, does something remarkable. It pushes electrons through that wire. It generates its own current from nothing but the field. This effect has a name, electromagnetic induction, and it was discovered by Michael Faraday back in 1831, long before anyone had a phone to charge. Faraday found that you don't need a wire to touch a magnet to get electricity out of it. You just need a magnetic field that's changing and a loop of wire close enough to feel it. Your charging pad is basically a fast, tidy electromagnet, and your phone's coil is the loop catching the ripple. That word close is doing all the work. A magnetic field isn't a beam. It's a bubble that balloons out from the coil and fades fast. Its strength collapses roughly with the cube of the distance. Move the coils a few centimeters apart, and the field reaching your phone is already a fraction of what it was at contact. That's exactly why wireless charging needs the phone sitting flush on the pad, not floating nearby. There is no long-range version of this trick, and that closeness still doesn't make it free. Every step in the chain, pushing current through the pad's coil, radiating the field, catching in the phone's coil, converting it back to usable power, bleeds a little energy as heat. Wired charging loses almost none of that. Wireless charging typically loses 20 to 30%, which is exactly why your phone feels warm sitting on the pad. That warmth is the energy that didn't make it into the battery. So the wireless in wireless charging is a bit of a magic trick. It isn't beaming power through your desk. It's two coils holding a tight, invisible conversation through Faraday's 190-year-old field, close enough to feel each other and nothing more. Slower, warmer, but wire-free at the point of contact. If you like your everyday objects a little less mysterious, that's what we do here. Subscribe at Cutaway 360. We keep cutting things open.